Okay, awesome. Well, welcome everyone, and thanks for joining us today on this, amazing Wednesday, to talk about building resilient applications and environments. And is less more? That's a little bit of a theme that we're going to weave through. This is a sponsor session. Both Michael and I work for Veeam Software. How many of you guys in the audience know who Veeam is? Okay, a good amount of you. Despite it being a sponsor session, we're not here to pitch you or sell you. A lot of the advice and information that we're going to be sharing with you guys today is applicable irrespective of what you're doing. So pay attention, take note, make sure that you're implementing it. A couple of introductions first. My name's Sam Nichols. I'm Senior Director here at Veeam Software, and I get to look after a lot of the fun, new, exciting things that Veeam is doing in the public cloud with Kubernetes, as well as our new Veeam Data Cloud platform, which is really transforming our offerings from software only to software as a service. And I'm joined by my colleague, good friend, Mr. Michael Cade. And before I let him introduce himself, he affectionately calls me our Chief Coloring In Officer, because despite his CTO name, Michael doesn't know how to use PowerPoint, so he always calls me up, and that's exactly what I do for him.
And that's why he's here. So I'm Field CTO at Veeam. I've been at Veeam for just over 9.5 years, and I sit in the office of the CTO, so feedback from our existing customers if you're in the room and put your hand up. Hopefully we've spoken at some point, and it's about getting that feedback into our product management team, into our R&D, so that we can make our products better and more available to everyone out there. And a lot of the stuff that we talk about later on in the session will be about the coverage of what we do in particular to AWS.
Absolutely. So let's get started. And first off, let's have a look at just what this dictionary definition of resilience is. You know, Veeam, historically known as a backup company, especially for VMware. That's just not true nowadays. We support over 150 types of platforms and workloads now, and we go much further beyond backup. So what I really want everyone to understand is this notion of resilience, right? It's the ability for a system, an application, a workload, a platform, an infrastructure to withstand and recover from some sort of failure, whether that is human error, whether that is just, a DDoS attack, whether it's some sort of other cyber attack. And we see a lot of organizations doing the right thing. You know, they're building multi-clustered applications. There's lots of high availability there. But we're seeing time and time again a lot of organizations kind of falling at that last hurdle, especially in areas like the public cloud, whether that's IaaS, PaaS, Kubernetes, because they're relying on a snapshot. And I don't want to say that a snapshot is a bad thing. A snapshot is a wonderful thing. They allow us to achieve very, very quick RPOs, recovery point objectives, so we lose as small amount of data as possible. And they are very quick to recover from as well. Very low RTOs, the amount of downtime that we're actually experiencing between failure and recovery. But what a snapshot is, it doesn't replace the need for a true backup. Right? Again, they're great for quick rollbacks to a very, very recent point in time, but they inherently are not very resilient to a number of these other challenges. And our own data protection report really helps highlight some of the areas where folks are really struggling when it comes to outage. Michael?
Yeah, I think if you look at these numbers, and we're not only talking about 10 plus years ago, we probably all had a data center to look after, with some virtualization, some storage, some hosts, maybe some physical servers. And that world over the last 10 years has exploded to these multiple platforms that we have to now consider and have that purpose-built resilience over all of those data services. So we have to bring that same policy-based engine to be able to protect those workloads. In particular with these numbers, there's a lot of numbers on here and a lot of pinky color, but I think the most topical one we hear about in the news is that cybersecurity event at the bottom. But I equally, every conversation I have generally is about the ones closer to the top, not necessarily natural disaster, but admin configuration error. Mistakes happen. I imagine if you're hands-on or have been hands-on, it's very easy to drop that database or delete that virtual machine that was running mission-critical workloads. I think they're just as important to provide resilience against than it is those cybersecurity events as well. But we're going to get into a little bit more about what that it all mean in regards to resilience.
Yeah, absolutely. And I always like to highlight some of the recent events. Maybe this one's not so recent. It happened in May, and I like to use both doom and gloom stories, but superhero stories as well, and this is one of those superhero stories. It's about a company called UniSuper. They're an Australian superannuation fund, essentially looking after people's hard-earned retirement. And they had performed a migration from an on-premises data center, largely built on VMware, to one of the other cloud providers that don't exist. And during that migration, everything's up and running, and this cloud provider that doesn't exist makes some sort of administrative configuration error to this account. And it ultimately brought every single account, project, there's a little bit of a hint of what platform it is, down. And if that organization had relied on just snapshots alone, snapshots are stored on the same media, in the same account, they wouldn't have been able to recover. Their only saving grace was a true backup that was stored on a platform outside of that public cloud platform. So they were able to bring back all of those records that managed that $600 billion in funds because they had a true backup living somewhere else. And we're going to be sharing some tips and tricks on how you can do that to really help understand. Another thing to understand, though, is around shared responsibility. Michael and I have been talking about this for 10 plus years. I think when a lot of folks move to the public cloud, they're under that misperception of, hey, I'm moving everything to the public cloud and I'm transferring all of that responsibility to them. And that includes the protection, the resilience, the security of my data. But that responsibility is actually a shared responsibility. And depending on the level of service that you are utilizing, whether it's IaaS, PaaS, or SaaS, you are transitioning varying degrees of responsibility to that provider. But you can see here in orange, right at the top, the data is yours. And it is always your responsibility to secure it, to protect it, to manage it.
The one thing I add here as well, it's easy to talk about the databases, it's easy to talk about the IaaS, the virtual machines, etc. that we have in our AWS accounts, but those VPCs, it's very easy, especially if you're across multiple different subscriptions in multiple different regions. You might have hundreds of VPCs that are controlling access into your mission critical workloads, and it's very easy to lock yourself out of that mission critical application by changing something. So as much as customer data normally means, oh, it's the database or it's the virtual machine, I think we have to also consider those configuration details around things like VPC. That's still data that is still important as well.
Absolutely, it's right there, right? Customer responsibility for security in the cloud, and there's network, I think it's the, right? So
Exactly.
Again, shared responsibility. Now, fortunately, there's a lot that has changed in those 10 years. Like before, it was like single-digit percentage points that folks were protecting their data on or in the public cloud. Now we don't really face that as much because a lot of people are leveraging things like snapshots, which you can absolutely manually manage or script within something like the AWS console yourself. But again, snapshots are not the be-all, end-all when it comes to a true, well-rounded data resilience strategy that does actually just go beyond snapshots, but also goes beyond backup and recovery. And that's really where this piece comes in, right? 85% of organizations are admitting that they have some sort of availability gap between what the business expects and what they're actually able to deliver. And a snapshot is one of many reasons why folks aren't able to deliver that. So let's start getting into some of the best practices. We'll start off with the age-old adage of the 3-2-1 rule. The 3-2-1 rule was actually started by a photographer, right? It's about 3 different copies of your data, 2 different types of media. One of those is off-site. And that was very, very easy to apply in the data center days, right? We had our primary backup living on some sort of spinning disk. We had a secondary backup that lived on tape media, and that tape media was shipped off-site to an Iron Mountain of the world. But when we start moving into this public cloud era, where we're constantly connected and we don't have full control over the infrastructure, the platforms, the software, a lot of folks looked to how we can implement this 3-2-1 rule into the public cloud. Of course, 3 different copies of data is your production copy on the application, virtual machine, database, whatever it is. Your second copy is your snapshot. I do want to say and highlight and reiterate, snapshots are fantastic as that first line of defense. But you need that third copy, and that third copy needs to be on a different type of media, and it needs to be away from the production environment account application. So we see a lot of organizations taking an image-based backup of that snapshot, and in AWS, they will store it in a dedicated account on S3 object storage as that third copy of data as a different type of media, right? Because an EBS snapshot lives on an EBS volume, a backup lives on object storage, and again, it's away, off-site. one copy offsite, and that could be in a different availability zone. It could be a different region, but that's lesson number one. Michael, anything to add to this?
Yeah, I think on that image-based backup, when you look at your virtual machines and how many people are running virtual machines with databases inside of those EC2 instances? Okay, a couple, right. So we see this quite a lot, that lift and shift model, and then they're on a journey to then re-architect that into, say, RDS or DynamoDB or some other managed PaaS service within AWS. That image level backup is about how do we take an application consistent copy of that as well. So when we go to the snapshot side, yes, you can go into the console, yes, you can use CLI, SDKs, etc. to make that happen, but it's not going to be aware of the database or the data service inside of that EC2 instance. So to have that ability to go in that and kind of pause that I/O, those transactions that are hitting that database is really important, because then when you come to recover that, we want the ability to have a nice clean restore when it comes to that database, and that follows through into the RDS instance as well.
Absolutely. This is just like a high-level architecture, I guess, of how that would look like. Yes, we've got Veeam here, but again, akin to what we were talking about earlier, that you can absolutely achieve something like this with other tools that are out there. The next piece is looking at a logical air gap. We've been talking about air gap for decades, right? Let's talk about tape again, right? Once that data has been written to the tape and you eject the tape and you put it on a truck and ship it off to Iron Mountain, there is that physical air gap between the environment and the backup. And if push comes to shove, even if you have a bad actor that completely brings your environments to its knees, you can just pull the tape out of the archive, upload it back onto disk, perform a restore, and great. But how do we do that in the public cloud where everything's constantly connected? Michael?
Yeah, exactly that. That separation, that zero trust, being able to have that. How do we simulate that tape requirement that we would have potentially had 10 plus years ago? I still speak to many enterprises that still have that tape requirement, even from a cloud perspective as well. And yeah, exactly. How do we then take advantage of things like immutability and everything that we're going to get onto as well?
Yeah, absolutely. And looking at AWS, they treat accounts as security boundaries. So again, irrespective of what you are using, place your backup tool and your backups in a dedicated account away from the production or production accounts. So make sure you use a tool that can support multiple different accounts. But that is your logical air gap. But doing that, go on.
Sorry, I was going to say that, and that also enables you to have a recovery perspective and subscription as to when bad things happen to that live subscription account, we can now restore to another location as well. It's because sometimes, especially if it's a cyber attack, that gets ring-fenced. The legal authorities are going to come along and they're going to say, you can't touch that anymore. We have to take it offline. We're going to close down that VPC, the access. So you need somewhere to be able to recover that from, be able to access that backup in a different subscription, in a different account, and then be able to then go on and restore that somewhere else as well.
Absolutely. There's a second part to that puzzle, though, which is really around leveraging this principle of, these screens are confusing, sorry guys, but what we've got here is just kind of what that logical air gap would look like. You can see the dedicated backup account with the backup tool, Veeam in this instance, and then the backup repositories in that dedicated account. But what you really want to do is leverage that principle of least privilege. Michael referred to zero trust, is leveraging IAM roles and permissions to keep the traffic that's going between these accounts to the people, applications, services, to whatever is the bare minimum required to perform those backup and recovery operations.
I think we've all probably done it. You can easily assign administrator access to everything in your subscription to get over a hurdle or get around it. Obviously, that's not going to be best practice. So we or any backup provider would have to provide that capability about being able to be granular when it comes to protecting those workloads with special IAM privileges and permissions.
Yeah, absolutely. Get your data into a different building, but if the door's wide open and anyone can come in and out, it's not secure, right? You're not going to have a secure backup to recover from. Other things include role-based access control, right? So I wouldn't trust Michael with my PowerPoint presentations because he doesn't know how to build them. So similarly here, why would I trust Michael to access my data protection solution and create backup policies or perform restores? He should just have read-only access so he can do his wonderful demos. Same with multi-factor authentication, right? Helping prevent those man-in-the-middle attacks, something you know, something you have. So really leading into that zero trust data resilience, leveraging identity and access management policies to help broker the connection between those different accounts and make sure that it is limited to whatever is necessary, but also those permissions are continually rotating and continually being deleted if they're no longer needed. Do you want to talk about immutability a bit?
Yeah, so I've mentioned this as well. So it's one thing having that one copy off-site in theory, in an S3 bucket, in a different account, in a different location. But I would say the bare minimum, and I actually wish AWS would do this by default, actually turn on that object lock API and the API versioning, so that by default, everything that you throw in that bucket is going to be immutable for a certain amount of time. Obviously appreciate that we're also seeing production-based workloads also live on that S3 bucket now, and they might not warrant or need that same immutability. But by being able to send that back up into that immutable location, now nobody, even if there is a configuration drift and there is some sort of security access that has been tampered with, then at least that backup is safe. Because even with God mode, administrator access, you can't have that access to that backup. You can't change it. AWS can't change that. They can't manipulate what that lock does to that backup or any file in that location.
Yeah, absolutely. And there's a ton of research out there that kind of just shows how these cyber threats like ransomware are evolving. And in fact, 95% of ransomware attacks now explicitly target a backup in order to cripple an organization's ability to perform a successful recovery. Right? So you make sure that every single backup has been made immutable, because if you don't do that, they're going to come in and encrypt it, and then you have nothing to restore from. So bit of feedback, I'll step over here. Immutability, write once, read many is critical. Just one pitfall to avoid, don't set the retention period into crazy numbers, because like Michael said, even if you have godlike access, you can't delete that. And if you have any sort of fiscal concerns or regulatory compliance that says you must keep data for this long and not a day longer, but you've set the retention period for immutability much longer than that, you're not going to be able to delete it, wasting money, and maybe more importantly, out of compliance. But we've seen with 95% of ransomware attackers now attacking backups, and they've caught on to that, they've kind of devolved to what ransomware was initially. That's another diagram. But what ransomware was initially, which is exfiltration of data. Right? So they're holding organizations ransom by saying, hey, I've got this personally identifiable information, company secrets, whatever it might be. I've downloaded it onto a thumb drive. I'm going to leak this if you do not pay my ransom. Immutability is not going to stop that. The only thing that's going to help prevent that is encryption. Obviously with AWS, you've got a number of options when it comes to encryption, but I'm going to give another story, which is, it's kind of funny, but it's a recent event whereby an organization had their data exfiltrated. And these ransomware attackers, these bad actors, aren't even interested in the money at this point. I think that they're just getting off on bringing organizations to their knees because they demanded the ransomware to be paid in French baguettes. So encrypt your data, or someone else is going to do it for you. Any other points on encryption around KMS?
I think both on the encryption side, we're talking about backups here, but actually it's very easy to go and encrypt your own RDS backups, your own IaaS, your own data as well, and making sure that at that point, if that gets exfiltrated and you've got the keys to that data, then you can unlock that. No, just because if you exfiltrate a database that is encrypted by you and those KMS keys, you've got the keys to be able to restore that data. And also the IAM piece, that doesn't just revolve. Think about this backup piece as this is just another application that has access into your data. All applications should have that IAM focused privilege and least privilege access to that as well.
Absolutely. So these are just some of the best practices around ensuring that an application is resilient, that the backup is resilient. A couple of other points around just utilizing these best practices as well is they're a lot more cost effective, so your total cost of ownership within the cloud, it can help you optimize costs. Looking at just relying on EBS snapshots alone, I've spoken to countless organizations that deal with snapshot sprawl, right? Tens of thousands, hundreds of thousands, millions of snapshots being stored for who knows how long. Snapshots live on some of the most expensive storage out there, EBS volumes. Depending on what region, it's about 5 cents per gig per month. If you do take a true backup and you store that on something like S3 even the most performant S3 starts at 2.3 cents per gig per month, so you're automatically halving the cost there. With a backup, you can perform things like compression, varies between vendor, but with Veeam, we can do 2-to-1 compression, so now that's a quarter of the cost. And that's just on S3. You start going down to Glacier Deep Archive for those really long retention spans. You start talking about fractions of a cent. So kind of less is more there, right? Less spend on data protection is more budgets freed up for other transformative initiatives, whether that's data warehouses, data lakes, AI, lots of things out there. Less is more when it comes to, less permissions is more secure. So lots of other good things to come around outside of just resilience here.
Let's just go on to that next slide, Sam, because I think it's important. So we've spoken a lot about the backup and the architecture of that and the resilience of that data and getting it into a place where it needs to be. I think it's also important, I've already touched on the application awareness, making sure that we are talking, or the backup product is talking to the application and making it consistent. I think also when it comes to recovery, you don't want to have to recover everything at once. If you've got terabytes of data, that's going to be a pain, and you only need to bring back megabytes potentially in some file scenarios. So having that granular recovery option, the alternate location if things were ring fenced in a cyber attack. Equally, depending on whether you're trying to automate things, do it through the CLI, through the management console, there should be an option to be able to do data management in a way that suits the business. You shouldn't be locked in. Not everyone wants to ever go into the management console. They want to be able to integrate this into CD pipelines and be able to protect that data as part of that whole process, and kind of a set and forget it type. Once you've set the foundations of that data resilience within your AWS account, and all of the data access, then I want to be able to just automate that. And that goes for all of the platforms. On all of the diagrams that you've seen, we used IaaS, so virtual machines, EC2 instances. We also used RDS, but there's so many services that are data services within AWS, alongside things like DynamoDB, EKS, if you're running persistent volume claims within your Kubernetes cluster, be it EKS, be it ROSA, Red Hat OpenShift on AWS. It's all persistent, and it's probably important data if you're keeping it, because you're spending money on keeping it. So with that, I'm going to get into a few of the demos, because I think the first line on the description of our session was actually showing some demos. So just to run through so there's 3 demos that I want to get to. One is going to be live, so everyone should keep their fingers crossed for me. In particular, one thing that we haven't touched on is that on-premises migration, a big migration, or the hypervisor Hunger Games, as I've been calling it, from a potential virtualization vendor on premises into another place where I can run these virtual machines. And it just so happens, because we're at AWS, we should talk about EC2 as a virtualization hypervisor, as it were. So we've got a lot of customers that are storing their data in that AWS S3 bucket in most likely an immutable fashion. In this demo, I'm going to show a very simple Ubuntu web server. It's got some important data on, and we'll get to not only just the backup, that's the easy bit, but equally, how can I look at migrating that from that S3 bucket into an EC2 instance, using the same tool set, using the same data that we've already collected for retention from on-prem, and turn that into an EC2 instance, and then provide the ability to then protect that again when it gets into EC2. So I don't know if this will autoplay. Oh yeah. So we're going to start off in Veeam Backup and Replication. You see here is my very, very simple hypervisor Hunger Games, and you can see that it's running in VMware vSphere, just one of the virtualization hypervisors on-prem. And we've got the option here to restore to Amazon EC2. And at this point, we can start to choose what restore point. Where do we want to pull that data from? So we might have a retention for months, years that we want to call from. At this point, we're going to say what AWS account do we want to use, what region, and what data center. In this instance, I'm going to use US East. Now we can start manipulating what that needs to look like as we restore that into our AWS account. We can add some tags, we can change the name. In this instance, I'm going to use gold backup because this is going to form part of the later bit of the demo. Then we're going to get to choose what that instance type is. Maybe on-prem that was 16 gig and it had X amount of CPUs. Maybe I want to change that here and see what it looks like with more or less. And then I'm going to say what disks I actually want to bring up. Maybe there's a config disk that I don't want to bring up. Also from a license point of view, hopefully you saw the estimated price per month. If you bring that license, we're going to do a cost analysis at that point and say it's going to cost you about $120 or whatever that might be. We're then going to get into what VPC we want to restore it to, what security group, what subnet, etc. So I'm just flipping through this. These are all either pre-created or you might see that we've got the ability to create new resource groups as well. If you want to assign it a public IP, not necessarily best practice, it's going to give you someone access to it, so be sure that that is the setting that you want to do. And then this helper appliance is going to help lift that data from the S3 bucket and move that into an EBS based storage layer. So we're going to choose the helper appliance instance as well. That gets spun up, it does the work, and then it gets pulled down, terminates, and we're going to choose to power it on. Now, I've sped this up. The laws of physics means that we still have to move data. Even though it's a very small web server, you'll see that we go very quick through this process, but what we're doing is we're basically saying, this is what we want to do, this is what the end game needs to look like, the desired state, and we're going to move that data, manipulate what that needs to look like configuration-wise. We're not going to touch anything inside. And then from there, if we go and look at our mission-critical application that we've just migrated simply into EC2, you'll see now it's there. And if I go to that web page, it checks the server environment. This is just a little app that I built. And if all goes well and it is actually in EC2, we should get a message to say it is no longer in our on-prem data center. We'll just wait for it to come up. And it should just flag to say, yeah, we're on the other side. So a very simple demo. And in terms of, okay, that's great. It might be test and dev, but now we want to protect that. We want to start pushing data to it. So now this becomes our production. So within Veeam Backup for AWS, we've got the ability again to create a new policy to protect that. We choose our default IAM role that has access. We could do it via instance name, or we could do it via tag. Now remember, I created that gold tag. I have other tags in here that can manipulate what we're backing up. I want to protect everything that lands in that gold backup. And that means everything that I now put into that tag means I will start protecting it with this policy. We can do that application aware snapshot as well, and then offload that into our S3 bucket. This is another S3 bucket in a different account that gives us that granularity of being able to protect that. This can be immutable. For demo purposes, I didn't do it to demo, bad practice of me. We set a frequency, a schedule of that. How long do we want to keep the snapshots for? Now this is very important because snapshots are going to cost you money, or a lot more money than putting these to S3. But we're going to give you a cost summarization of what that looks like. We've then also got the ability to go and test that configuration. And this whole process is not new from Veeam. We've had this for a number of years. So quickly start this. We're going to go and back it up. It's saying what the retention period is on that S3 bucket. So it's warning me that I'm going to keep 14 days retention on that S3 bucket. We're then going to zip through this. You see that we're going to create a snapshot and then an S3 export of that backup. And that snapshot, as Sam was saying, that gives us a really fast recovery point. If we've just made a slight config change and it's not quite right, we can roll that back. However, if something bad really happens to it, we might have to go back to that S3 bucket. From a restore point of view, we've got instance restore, that's the whole thing. We've got a volume restore, so a particular EBS disk, or we can go granular. Now, this setting here, the additional restore mode, this means that we can recover directly back into that EC2 instance. Or we can create a file level recovery explorer, and that will give us a link As a backup admin, we can then download that file. This is a website or a web server, so I can now navigate into that hierarchy. I can go and download all the files I need, the index.html, but this could be a database server, and we could go and pull down individual items for that as well. So if I navigate to that, and then we've kind of got this shopping list or restore list that allows us to pull down multiple files at once and then restore that wherever it needs to be restored. It might be another test and dev type environment as well. And that should be added to the restore list. You see that now we've got a list of the files that we want, and we can download that. If we'd have clicked that in the wizard, we'd have been able to send that directly back into the live server. Okay. Second demo is more focused around the RDS. And this is an RDS scenario where maybe that MySQL instance is a little bit too open, and we've enabled a bad actor to gain access into that RDS instance and do some malicious stuff. But luckily, we've got a backup of that is being stored in S3 and then being replicated over to a different region as well. So I'm using MySQL Workbench really just to interact into that RDS instance. Did it play? Is it playing? Yeah.
Now it is.
Good stuff. So we connect into that RDS instance. You can see, show databases. I'm not a SQL. I can't write SQL very well. But you can see I've got a long list of important names, my mission critical database here. All looks very readable. These are all analysts, so if there's any analysts in the room, I apologize for what's about to happen. We're then going to run a very simple script against that is going to encrypt all of that data. As you can see, encrypted data is bad when you didn't do it. I think you might have mentioned something similar earlier. So bad state of affairs for our mission critical application and our data alongside that. So we come back into our Veeam console. We've got the ability now to recover. We need to recover this. Now we could do that from a snapshot, or we could do that from our exported copy in our S3 bucket. So we want to restore to the original location. There's nothing wrong with the database. So in theory, the database is still there. The data inside that database is no longer any good. Mistakes were made, so we need to fix those mistakes. And what this is then going to do is start up the restore, so we can choose the restore points that we have available to us to choose from, and then start that restore process. And this is going to overwrite the existing RDS in this case, because it's there, but maybe that malicious actor actually gained access to your management console, your AWS CLI, your access keys, and started deleting services or data services within. So you can see here, I'm actually using the storage snapshot for really fast recovery. And you can see that the instance restore is taking place. Now, fingers crossed, as I know I've recorded it, that when we reconnect into that RDS instance, all of that list of names and critical information is all going to be back for us. So really just emphasizing just having that copy when bad things happen, and they will happen, whether it's an accidental deletion, a misconfiguration, a cyber threat that's going to get you on the front page of the newspaper, it's going to happen. So you see there, that restore was relatively quick, and now if we reconnect to that, we should, in theory, have a list of good data to show. So just to quickly go through what this outline looks like. I don't know why that's come out like that. Let's build it out. So Kubernetes. I haven't really spoken about Kubernetes, EKS, for example, or ROSA. We have a product called Veeam Custom for Kubernetes that protects any Kubernetes distribution, be it OpenShift, be it an upstream Kubernetes or managed Kubernetes environment. And really what we're doing there is we're leveraging, again, the snapshots, but then equally providing that same capability about being able to export that out into an S3 location, in an immutable S3 location. So in this live demo, that hopefully is still working, this will give us the ability to, it's just a simple WordPress, so a very simple front-end web server with a back-end MariaDB database. Now, I started playing around with putting that to RDS that we also support, but just for simple terms, I just wanted to have a stateful application inside of Kubernetes. What Kasten is going to do is we're going to leverage the CSI driver within EBS to take a volume snapshot, and then with that, we can then restore when bad things happen. So hopefully you can see. Here's my very, very simple WordPress site. We're going to go and manipulate this site just by simply adding or changing an aspect of this data. If I remember how to use. This is not the time for the internet to stop working. So let's replace that. Let's do it with that one. A home lab picture, and then let's save that. But imagine, obviously that's not that malicious, but imagine that being a business e-commerce website that has all of your catalog, has everything that is mission critical for you making money as a business. Something's been manipulated, a SQL injection has happened, and it's all running on Kubernetes. How do we get back from that? How do we remediate from when that bang happened, that bad thing that happened? So in Kasten being deployed within your Kubernetes cluster, a Helm chart deployment, we're in the AWS marketplace as well, is we dynamically discover the applications that you have here that you see in this first widget. I have a couple of applications. I have Kasten itself, but equally I have a couple of demo apps. In particular, the one that we're worried about is this WordPress one. So I need to go here, and there's a restore that I made earlier. And this top one is our snapshot, so very fast recovery. And this one is our exported copy that goes out into S3. Now I know we're just changing one little thing. The snapshot should be a valid restore point. It's going to be really quick. And then from a restore point of view, we've got some options. Do you want to send it to a different namespace, i.e., do I just want to clone what that looks like and start doing some remediation work myself? Do I want just the data? Do I want to transform what that looks like? And this becomes really handy if you're moving between potentially an on-prem Kubernetes cluster into EKS, for example. We can manipulate what that application needs to look like. So that could be storage class. So a storage class on I don't want to pick on VMware and VMware Tanzu again, but if you're running a VMware Tanzu cluster and you want to get into EKS, the storage class is going to be dramatically different. It's not going to be called EBS SC, for example. So you're going to want to change that. You're going to want to transform that. We can do that here as part of this, restore process. Equally, we might just want a disaster recovery. We might want that Kubernetes data in another cluster somewhere else. So we've started that restore process. And now while that is starting, you'll see what we're going to restore any second is we're going to start bringing back the persistent volumes, but equally the whole application. Because I didn't get granular, I'm going to start just bringing back all of the persistent volume claims, the services, the deployments, the stateful sets, etc. So this is what the application looks like up front. If I do a watch, you start to see, right, we have nothing. So we've literally just got rid of that bad data, the manipulated data, and now we're going to start that recovery process. But I just want to take that time to go back to the dashboard. So I have a policy created to protect my mission critical WordPress application. And in here is where we define what that needs to look like. What's the name? What are we going to do from a backup frequency, a snapshot frequency? What are we going to do from an export point of view? Where are we going to send that? In this instance, it's Amazon S3. And then going back to my application consistency point, we have the ability to inject a blueprint. So we can speak natively to Postgres, pgdump, MongoDB, etc., and be able to manipulate what that needs to look like. That's really for that transactional workload. Clearly, there's not much going on my WordPress site, so we don't need to worry about that here. From another dashboard point of view, it gives you an instant feedback on what production data you're using, as well as what snapshots we have and what exports we have. So ideally, you're going to see, we have 110 gigs worth of snapshots. That's going to translate into spending money. So hopefully then we start to offload some of that into S3 to get away from that EBS and that more expensive. And that's going to depend on the nature of the application that you're protecting, whether it's a mission critical application, a gold tier application, or whether it's a tertiary thing and we don't want to keep many snapshots. Okay, we're 6% in. In terms of locations where we can send it to, you can see here I have a location profile set up as AWS. This is our S3 bucket. If we go and add another, you've got here S3, and that allows us to set up that immutability, that object lock capability. So hopefully, okay, the restore's finished. And you can see here that everything's come back up, but you can see that it's only 93 seconds old. So we have literally refreshed that application, we've brought back the state, and in theory, if I go back to that web page, we should have our existing or our pre-existing application. Let's just do this. I want to get that service. And if I navigate to that, and everything's back up and running there. So quick little tour of what Kasten looks like. I mentioned this earlier as well, is that maybe you're not running stateful workloads inside of that Kubernetes cluster and you're actually a stateless cluster, but you're reaching out to a database. I would say that it's very easy in the Kubernetes world to say, oh no, I only have stateless workloads, stateless applications, but that application is going to be connected to something. That could be an RDS instance. Kasten has the ability to reach out to that RDS instance or any cloud-based PaaS service and be able to start protecting that as well as part of the whole application and being more application-centric around that.
All right, we'll start to bring it home then. So, I mentioned at the beginning this wasn't a pitch. Like, what we really wanted to do was give you some best practices that everyone here can start implementing today. But if you don't know who Veeam is, the numbers speak for themselves. We've been around for 18 years now, #1 global market share when it comes to data protection, data replication, and that's not just on VMware, it's not just on AWS, it's all these other different platforms out there. So if you are living in a hybrid multi-cloud world, you've got some legacy applications on physical servers, on VMware, you've got some modern applications running on Kubernetes, on AWS, whatever it might be, Veeam is really just one throat to choke to help you secure, protect, recover all of those different workloads. And like Michael has shown as well, it's the portability component as well. Like making sure that you're not locked in or out of a specific platform. So Michael showed recovering an on-premises virtual machine to EC2. It goes in both ways. It goes across all the different platforms. So whether it's a disaster recovery scenario, whether it is a migration, Veeam will be that tool to help you ensure resilience for the application at its source, move it to wherever you want to go, no questions asked from us, no additional licenses to be procured, land in a new target, and then automatically just start being protected using the exact same platform. Thanks for the new remote. Here's just a good idea of the breadth of platforms that we do protect. But the next slide is just kind of looking at it when it comes to an AWS perspective, right? So we've got EC2, we've got our VMware Cloud on AWS. Anyone paying attention noticed Amazon EVS, Elastic VMware Service. I did a new Google image search for that. There's no icon for it yet, but it did give me an Amazon electric delivery vehicle, which I've put here. Number of different storage options, databases, different Kubernetes flavors, data warehouses like Redshift, and as well as VPCs like Michael was talking about. So the platform protects all of this, especially when we start getting into Kubernetes and all the different distributions, are hundreds available there. So again, just the industry-leading platform here to ensure that anything that you do is resilient. Anything else to add, Michael? What else do we have? And we spoke a little bit about, what does data resilience truly mean? We spoke a lot about backup and data recovery, but there's other components that are absolutely critical to being able to do this right. That data portability piece that we just spoke about, being able to move different workloads, applications, sets of data across different platforms is going to be critical from a disaster recovery scenario, whether that is from one region to another or out of AWS or other cloud providers back on premises or any different flavor that you want, again, just to ensure that that application stays online. I gave you the example of Unisuper earlier about how critical that data portability component is. Without a true backup out of that other cloud platform, they would not have recovered. The security components as well, right? It's not just about immutability and encryption, but it's around that, all those zero trust components as well. And then the data intelligence. We talk a lot about AI. Michael, do you want to talk? Should we go into a little bit about intelligence?
Yeah, I think my say, like obviously from an intelligence point of view, it wouldn't be 2024 if we didn't talk about AI. But ultimately, think way before the AI piece. Intelligence is about leveraging the data that you have to glean information and intelligence from that data. You can't just throw garbage into an AI model and expect to get useful stuff out. And something that we've done for many years is about not just backup and recovery, it's about how do we expose that data to third-party solutions around data classification, security posture management, to understand what that data is so that we can start to have that story about data lifecycle management and data hygiene. Because if you're backing up everything that you've got, then potentially how do you know what's the important stuff, and understanding what that is going to help you remediate and get back up and running as fast as possible. I think also that intelligence part is about understanding that your backups are in a great space, they've worked, and you've verified that those backups are happy, as well as things like malware detection. As that backup gets created, that's a prime time to be able to run it against antivirus type software and understand if there's malicious files or vulnerabilities within that data. So I think before we even get to the AI part, and we have started to put things like anomaly detection within that and starting leveraging that, but it's all under the hood. And I think that's the power of AI, should be hidden away. Everyone's built a chatbot. We've got a chatbot that you can interact with your backups and you can start to understand what has happened. But it's not something everyone's got that capability. It's about how do we enhance the remediation of that bad thing that's happened, the bang, but equally, how do we help prevent bad things from happening? And being at Veeam for 10 years nearly, we're very good at talking about the remediation, the rite of bang. The US Navy SEALs use this concept of the bang being something bad that happens, and then how do you react to that or remediate that? But equally, they have this left of bang, which is the prevention. And we have been very good at talking about the prevention, the remediation. How do we get you back up and running when bad things happen? Equally though, where we can help, and we've started to do that over the last 2 years of product development, is that left of bang, that prevention. How do we hook into those household names that you see on the show floor and get a smoke signal when something bad's happening inside the network or inside the data, the storage, and then get that smoke signal so that we can act upon that, so that we either start a remediation and go into a different location, or we stop access. We can do a lot of things on that, and all of that is provided with AI underneath the hood and a lot of ML from that perspective as well. But it's not just a chatbot and being able to leverage that.
All right, well, we're butting up right against the holidays, and in the spirit of giving, Michael and I are going to give you 11 minutes and 46 seconds back. But if you do have any questions, please come up to the front. Make sure that you ask those. Michael and I are here to help. We'll be around the show floor. Thank you very much for coming, and hope you enjoy the rest of the show.
Cheers.